Alrighty, friends, we have a lot to do in the next couple of minutes, so I'm not going to take too much time for pleasantries. Hope you're doing well today. I am talking to you from Sunday. It's a little bit rainy outside right now, but I'm hoping that you got the chance to enjoy your weekend if I forgot to tell you to do so in class on Monday. We just finished up with these two units. We know how to create and manipulate variables in Java. We're really good at that and performing calculations and simple operations. We've also gotten good at using class data types to store more complex information, and we can use that to simulate real-world problems. But the value in programs really comes from writing programs that we can interact with, and that start to make decisions for us. So today I want to talk a little bit about the beginnings of tools we need in Java in order to do that. And it begins with the fact that I have been hiding something from you all. We've talked a little bit about some of the most common primitive data types, int, double, and char. Remember, we use char for letters, are really familiar ones. But the truth is that I have been keeping a secret from you. I haven't told you about a data type that is super duper duper important. And it's called a bool. It's called a Boolean. Now, integers save integers, doubles save decimals, and char save letter. And you're probably wondering to yourself, well, what the heck does a Boolean save then? The truth is, a Boolean can only hold one of two values inside of it. There are only two possible values that a Boolean can have, either true or false. Now the question is, why would we ever want to actually use something like this? Why would we ever want a variable that only represents true or false? If we can evaluate as true or false, then we can make decisions within a program. If we can evaluate something as true or false, then we can make decisions within a program based on the result. And that's where things really start to get interesting here as we go through class today. For us to make our Boolean value a little bit more interesting, we have to use what's called Boolean operators. If you open up your 3.1 notes that are attached to this, you'll see all of the Boolean logic operations that immediately follow from that we have access to today. While a Boolean itself can only save true or false into it, where this starts to get interesting is when we have it evaluate a result to true or false and save it. We can have our Boolean variable store and save the result of an operation that we've identified is either true or false. And we can use what's called these Boolean logic operators in order to do it. Say, for example, you had a scanner, read an integer, and you had a program where you needed to decide if that integer was greater than 3. If you write it to the right of our Boolean operator here on the left, you can use this symbol to compare greater than, and it's going to give you a true or false result. In this case, it evaluates the true. And if you are going to put in something that's greater than 3, or if you put something in that's greater than 3, it'll evaluate to true in that case. And the Boolean will have false saved into it otherwise. We can use these logic operators to compare a variable that we have to a condition, and then we can get the result of it that we can use for later. You might have guessed at this point that if there's a greater than 3, there's also a greater than or equal to 3. A less than 3. Or less than or equal to 3. This will save the result of comparing a specific variable x into or against maybe another value. And then we can save that result and use it in the future. Take a quick guess, pause yourself, evaluate each of these below, pause the video, if x equals 3, and see what you come up with. Pause the video, evaluate each of these below, if x equals 3. Now that you've unpaused, you can find the answers in the example over here to the right. Now, we've got ways here of checking if Booleans are greater than or less than, or maybe greater than or equal to, which maps a wider range. But what if we want to check if an integer, double, or a string is exactly equal to a specific value? What if we had a program where we were hoping someone would type in wallaby as their favorite animal, or we were hoping somebody would type in 3.0 as their favorite number? We have a way of checking that too. And then for primitive types, what that's going to look like is the double equal sign. The double equal sign checks if a primitive value, so in this case that's an integer double, is equal to whatever's next to it. The reason that we use a double equal sign is because in Java, a single equal sign means set equal to, while a double equal sign means checking. In the same way, that there's a check if equal, there's also a check if not equal. That works for primitive types. An exclamation point and an equal sign means check if not equal. So this code will check if a letter is not equal to E, and because it is equal, in this case, it'll return false. It would return true if, say, D were a different letter than E. In this case, since it's same, it'll return false and save that result into F. Remember that these Booleans are saving a true or false value of whether the statement to the right is actually true. Now this double equal sign and this not equal sign will work pretty well for primitive data types. But for a class data type, like a string, we actually have a method that goes after our object name that will check if two things are equal to each other. For example, say we had a string answer that were equal to Mr. Barron, and I wanted to check if that were equal to Mr. Barron. I could write answer, which is my object name, dot equals, and whatever I'm comparing it to, for example, another string here, goes inside of these parentheses. In this case, this will actually be false, because it's case sensitive. Answer has capital letters, while Mr. Barron has lowercase letters. The last thing we need to keep track of from our set of Boolean operators is that we can actually check more than one thing at once. Maybe we would want, for example, change these variables so they have better value, to see both of these numbers were above 8. What if, for example, we want to check if both of these numbers were above 8 instead of just 1? We can use what's called the AND symbol. Which means that we write two Boolean comparisons in parentheses. Put a little AND in between them. And this will evaluate to false because our 5 over here for z is less than 8. This is a situation where using AND requires both of them to need to be true for the result to be true. It's kind of like it evaluates these two things individually. Y is greater than 8. Z is greater than 8. One of these is true, one of these is false. In order for them, the overall statement H to be true, they would both need to be true in this case. And we have one more operator that's similar to this, but instead of checking if both things are true, it checks if one of them, or at least one of them, is true. We call it OR. It checks if at least one condition is true. So this will check if y is greater than 8 in this case, which is true because y equals 10. It'll check if z is greater than 8, which is false because z equals 5. But these double vertical lines right here mean OR. You might have seen this in like your geometry class before, and in OR symbols. If at least one of these conditions is true, I is going to evaluate to true for us. The big idea of what we've just seen is that we now have a way of checking to see if variables are specific values. We can check if they're greater than or equal to, or any of the corresponding operations. We can check if they're exactly equal to something, or not equal to it. We can check to see if a string is equal to a particular value, and we can also write statements that will evaluate more than one of these conditions at once and save the result of whether they're true or false. There's a brief video that follows this where we actually start to look at how this makes sense and is implemented in the code. It'll look a little bit familiar for anyone who's taken the intro class or who took robotics with me last year. Follow on to the next playlist to watch that.